Here we have a grade 9 June 2019 examination paper. It's going to have a bit of a mix of paper 1 and paper 2. Should take you about 2 hours to do, and it's worth 100 marks. Now, just quickly, and by the way, I'll quickly add something and then I'll add another something. If you want to download the paper, just check the description below this video. Okay, so, little story. Grade 9 was my absolute worst year. People think that I'm just this maths genius and I was born like that. Not at all. I can show you reports. I failed my June examinations for grade 9. I got 27%. If I had it here on my computer, I could actually just put it on the screen right now, but it's just going to take too long. But honestly, if you ever wanted to know, and you could send me an email and I can show you those reports. Like, I'm not lying. I failed grade 9 June maths. I think at the end of the year of grade 9, I got about 40-something%. And I remember going to fetch my report at the end of grade 9, and I was sitting in the car park with my mom, crying because I was sitting in the car, and she said, okay, you got to get out the car and go fetch your report. And I honestly said, Mom, I think I have failed and I'm not going to grade 10. So I understand. Grade 9 was my worst year. Grade 12 was my best year. So what happened? Well, what changed? Well, it only really changed for me in like grade 11, in my term 3 of grade 11, where I just one day decided I'm done being lazy and I'm just going to start studying like crazy. And I literally gave my parents my cell phone. I gave them my cell phone. I told them to keep it during the daytime. I gave them my PlayStation 2, which was a PlayStation 2 at that time. Took my TV out my room, and I literally just started studying, and my marks just started to improve, and I finished matric with amazing results. But I was never this naturally gifted person. Not at all. I was super lazy in grade 9. I would get home every day and just want to go play PlayStation. Like, that was amazing. But if you are in that position now, just give up. Stop with the PlayStation. Stop with the whatever you're doing, the Xbox, the wasting time on your phone, and just start studying, okay? Just start studying, and doing your part. You know what you have to do. Don't be lazy. Don't sit in class and not listen to the teacher. Don't have that arrogant mindset where you think you don't have to put in the effort and you don't have to work out hard. I know you want to be successful. We all want to be successful, but just do what you got to do. You know what you got to do. Okay, so give up the things that are holding you back in life, and I'm super happy where I'm at in my life right now because of the choices I made in grade 11, where I decided to switch everything around. So this is a long introduction, but I just want to tell you that I nearly failed grade 9 maths. I'm not this naturally gifted person. People think I am now because I've just practiced so much that it just comes naturally now. Okay, so wishing you all the best, whether you're doing really well right now or whether you're in a super bad place academically. I want to tell you that you are your biggest problem. You need to stop with the things that are holding you back in life, and you need to decide what you want to do. Okay? You know it. There's no such thing as you're not clever enough. It's not true. Maybe that's true when we start thinking about higher things like studying rocket science or PhD engineering. But for high school level, you have got this. You can do this. Trust me. You know that you are not giving it your best. Okay? You cannot look at me in my face and be honest and say you are giving it your very best. Because if you did, you would be super, super successful, and you know it. Okay? So that's my introduction for you. Let's go smash this exam paper now. And if you're in a bad place right now, I don't expect that you're just going to all of a sudden become better tomorrow. It's going to take time, but you got to make that decision that you're done with laziness, and you're going to start improving. And once you make that mindset, after 2 weeks, 3 weeks, a month, you will start seeing results already. Okay? I'm wishing you the best. Let's do this paper. So question 1 is actually I don't want you to do question 1. It is completely incorrect. It says here, which number is a prime number? None of these numbers are prime numbers. I'll prove it to you. The number 25 can be written as 25 times 1. It could also be written as 5 times 5. So a prime number is only when it has 1 and itself as factors. For example, the number 7, you can only write that as 7 times 1 or 1 times 7. There is no other way to write out the number 7, so 7 is a prime number. What about number 42? The memo says that this is the correct answer. But 42, if you work that out, you could write that as 1 times 42, but you could also write that as 2 times 21. So that is not a prime number. For this one over here, 27, well, that's the same as 3 times, not 3 times 3, Kevin. I was thinking of 3 to the power of 3. 3 times 9, and then 27 times 1. And then negative numbers are never going to be prime numbers. So all of these are composite numbers. They're not prime numbers. So there is no correct answer for this one. So yeah, what a silly question. Okay, so now we're going to go into this question over here. It says the annual increase in the price of goods and services based on the previous year's increase. Okay, so you know how our parents always talk about how things back in their days, 95 years ago, was super, super cheap. Like they'll tell you how a Coke was like 2 Rand, and now when they buy a Coke, it's like 20 Rand. Well, the way that the numbers go up like that is due to the process called inflation. The numbers become larger. It inflates, okay? So it's definitely not going to be a loan. A loan is something that you get at the bank where you ask them for a certain amount of money. The interest rate is just the percentage that something increases or decreases, and depreciation is when your items that you own decrease in value. For example, the car that you maybe have, well, as a student, I doubt you have your own car, but like, you know, a car's value becomes less and less over time, okay? And that is just depreciation. So the answer for that one would be B. For this question, you can literally just go and type this all on your calculator, because in this type of exam, you would be given a calculator, and it's only worth 1 mark, and it's multiple choice, so you don't have to show your answers. You're working out. You just have to calculate it. So if you had to go work this out on a calculator, you should end up with a final answer of negative 16. With this question, we need to add these two parts together, okay? Now, so you can think of this as a half x, so a half x, and then this here I would change to, you don't have to. You could actually just go type this on your calculator immediately because it's a multiple choice question, so you don't need to show you're working out. So you could just go type in a half on your calculator, plus 1 3/4. Now be careful with a Casio calculator when you type this part in. You can't just type in the number. What a lot of learners do is they'll first go make the little fraction button and they'll say 3/4, and then they'll press backspace, and then they'll put a little 1 over here. That won't work. If you do that, you're going to end up with 3/4, and that's not correct. On a Casio calculator, you have to press the button shift first. So you first press shift, then you press the fraction button, and it should open up a nice little fraction like this for you. Okay, and then you go fill in the 1, the 3, and the 4. That's how you do it. So we're just going to say a half plus that, and that gives you 9/4. So if you take a half x plus that x, you're just going to end up with 9/4x. But now we don't see any 9/4 here, and that's simply because they're taking this fraction and they're converting it back into a mixed number. So how do we do that again? Well, if you look at the number 9/4, the number 4, how many times can 4 fit into 9? Well, it can fit in twice, because that would give you 4, 8. So then, okay, so that would give you 8. So then how much is left over? Well, there's still another 1, because to go from 8 to 9, you have to add 1. So let's just go through that again. The number 4 fits into 9 how many times? Twice. And what does that give you? That gives you 8. So what we had was a 9, and so we just put we still have 1 left over there. Okay, if you want to check your working out, if you had to convert this into an improper fraction, then you would say 2 multiplied by 4 plus 1, which is 9/4. So you see how it works? Okay, so the answer is going to be A, 2 1/4x. Complete. The next term in the sequence, 1, 4, 9. Okay, so let's see what's happening here. So what's happening here is that they are taking all of the square numbers. What are square numbers, Kevin? Well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So look at the first 3. 1, 4, 9. 1, 4, 9. So what would be the next term in the sequence? Well, that would be 4 squared, which is 16. So the answer is B. This one says that the price of maize decreased from 1,280 Rand to 1,275 Rand per ton. What is the percentage decrease. Okay, so percentage increase and decrease, you get so many different teachers who use so many different weird methods of how to calculate this, but I'm going to show you a simple technique. So if you want to work out the percentage increase or decrease, all you do is you take the biggest number, you minus the smallest number, and you just divide that by the starting number. So which number was first? Which was the price of the maize first this one, or was it first this one? That's what I mean when I say start. And then you're just going to multiply that by 100. So wait, Kevin, you're telling me that the formula for increase and decrease is actually the same? Yes. Okay, so as long as you take the biggest number, take away the smallest number, and you divide it by the starting number, that's all. Okay, so the biggest number is 1,280. The smallest number is 1,275. What was the starting number? So what was the price of the maize first? Was it first this price, or was it first this price? Well, it was first this price, and then it decreases to that price. So we're going to put 1,280 multiplied by 100, and if we do that, we should end up with 0.39%. The sum of the interior angles of a quadrilateral. So what is a quadrilateral? A quadrilateral is any four-sided shape. Now that could be this, and that. It doesn't have to be a specific shape. It could be there, and there. It doesn't matter. But what we know is that if you take any four-sided shape, I'll give you a square as an example. If you look at all the inside angles, if you add them up for any four-sided shape, maybe you want to do a rectangle. Not all of them have 90 degrees, but I'm just trying to show you an example. But any four-sided shape, if you add up the inside angles, it'll always add up to 360 degrees. The theorem of Pythagoras. Okay, so we know that Pythagoras says that if you want to calculate the longest side of a right-angled triangle, so it must be a right-angled triangle, the way that you calculate the longest side, okay, so which one is the longest side? Yes, I know you can see it looks like that one, but how would you know? It's always the one that's opposite the 90. That is the longest one. Okay, so to calculate that one, you plus these two together. But you don't just plus them together like that. You square them, and then you plus them. Okay, and then if you do that, that'll give you this one also squared like that. So what we're saying is to find this one, you always plus the other two together. So the correct answer here would be D, which says that you're plussing them, and then you're saying the square of each one. If A is 70 degrees and B is 110, then if you add them together, 70 plus 110 equals 180. When two angles add up to 180, they are called supplementary. But then, Kevin, what is complementary? Good question. Complementary is when you add the two angles together and you end up with 90 degrees. If that happens, then that is called complementary. But when they add up to 180, then it is supplementary. Okay, this question says, in triangle PTM, PT and PM are the same, so we can see that they're showing us that those two are the same, and they're saying that angle T is equal to X. The first question says, well, the only question, it's multiple choice, Kevin. Calculate the size of angle P. Okay, so we know that in a isosceles triangle, which is when you have a triangle with two equal sides. So let's just make some notes for you. Two equal sides means we can call it an isosceles triangle. What does it also mean in triangles? If you have two equal sides, then it also means you'll have two equal angles. Did you know that? If a triangle has two equal sides, then it has two equal angles. If it's got three equal sides, then it's got three equal angles. If it's got no equal sides, then it's got no equal angles. So, have a look at this side. It is between this letter and this letter. So it's between those two. So then I want you to look at the other letter, the letter that's opposite, which would be this one. Okay, so that means that this arrow goes to that one. Now I want you to look at this side. Now this side is between this letter and this letter. So if you look to the opposite letter, then if you draw an arrow, then it would look like that. So that means that this angle and this angle are going to be the same. I'm not going to give any reasons because this is a multiple choice question, so that's x. Now, we know that these three angles must always add up to 180 because triangles always add up to 180. So we know that if you take angle P plus angle T plus angle M, it must add up to 180. So angle P plus X equals to 180. And so if you had to get angle P by itself, it would be 180 minus X, and so angle P would be 180 minus 2X. And so this answer is B. This question wants us to evaluate, but it's only worth 1 mark. So you can just go type this all on your calculator so long, and if you do that, you end up with 3082.1234. Now, some of you might have your calculator in a different setting, and it might give you the answer in scientific notation immediately. So we need to convert this back to scientific notation. They should have said here evaluate in terms of scientific notation or whatever. But we know that for scientific notation, you're just going to take the first number, then you're going to say comma, and then you're going to put all the numbers until it just becomes zeros. So there we go. You see how after there it just becomes zeros? Then you're going to say times 10, and then you're just going to count how many. So you've put the decimal over here now. So how many decimals is that? 1, 2, 3, 4, 5, 6, 7. And there's your answer. This question says, if A is minus 1, B is minus a half, and C is 4, then what is the value of this? Okay, so you see how they have A squared. So put a little bracket with the square, and just put the A inside that. Then there's a minus over here. Now what a lot of learners would do is they'll do something like that. They'd say, but that's not correct. What it's saying is that there's a minus, and then there is a B squared. So then open your bracket and put the B inside that. Then there's a plus, and then there's a C, like that. Okay? Now, obviously it's for 3 marks, so you can't just go type that all on your calculator, but you could type that part on your calculator if you want to, so that'll give you positive 1. Then there's a negative here. Please don't put the negative inside there because there's a square. So rather just write it as a negative. So just say negative. Then type that on your calculator with the brackets, which would give you a quarter, and then just say plus, and then that is just going to give you 16. Okay, now here we have a fraction. Now, whenever you are adding and subtracting fractions, you need to get a lowest common denominator. So this you can think of as 1 over 1, and this is 16 over 1. Okay? And then this is 1 over 4. So what is the lowest common denominator? Let's just write this. It looks weird, doesn't it? What is the lowest common denominator of those 3 numbers? Well, that would just be 4. So we could say the lowest common denominator is 4. If you said 8, that's also okay. But then in your final answer, you would have to simplify your answer a little bit more than if you just chose 4. Okay, so what that means is you're going to have to multiply this number by 4 at the bottom, but what you do to the bottom, you do to the top. This you don't need to do anything. Here you're going to have to multiply by 4, and here you're going to have to multiply by 4. So you now end up with 4 over 4, take away 1 over 4, plus, now what is 16 times 4? That's 64 over 4, and this is just going to give us 67 over 4 as our final answer. Simplify. Okay, so this one's for 2 marks. So what we have here is we've got 1, 2, 3 things that we need to multiply together. You are only allowed to multiply 2 of them together at a time. So which 2 would you like to... Well, I can't really ask you a question. That's pretty awkward because you're not going to reply to me right now. But you can choose any 2 and you will get to the same answer at the end. What I like to do is I like to leave this number alone, but you could have chosen that number if you wanted to, and I'm going to choose these 2. Now, when you get the answer from multiplying these 2 brackets together, keep that answer in a bracket as well, because we still need to take care of the minus 2. So we're going to say minus 2, you're going to open up a big bracket, and now you're just going to go do your multiplying out. This is where a lot of learners like to use the FOIL method, and if you don't use FOIL, then that's okay. I don't actually use FOIL normally, but some learners like it, okay? So what FOIL stands for is, F stands for first and first, so it means the first one and the first one. So what is x times x? Well, that's x squared. What does the O stand for? It means the outer. So it's the outside one How do I explain that a little bit better? Let me show you here. These are the outsides because they're on the very outside, and then these are the insides. Okay, so those are the insides, and those are the outsides. Okay, so here it says outside multiplied by outside. So that's the outside one and the outside one, and that is going to give you 3x. What about the I? It stands for the insides, so that's those two, or these two. So that's going to be 2x. What does the L stand for? The L stands for the last one and the last one. So the last one in this bracket and the last one in this bracket, and that would give you a 6. Now what happens is you are going to go, we could just go put these two together. Remember that when you put those two together, it is not going to become 5x to the power of 2. You're just adding them together. So 3x's, it's like, hey bro, here's 3 apples. Hey bro, you want another 2 apples. How many apples do you have? You don't have oranges now. It doesn't change and become some weird thing. No, you have 5 apples. So it's just going to become 5x or 5 apples. So 3x's and 2x's, if you're just adding them together, that's 5x. Yeah, but Kevin, my teacher said you must add the exponents. That's when you're multiplying. When you're multiplying these numbers, then you're going to take these exponents and then you would add them. And so that would become 6 because you're multiplying, and then you would add the exponents. Okay? But here we're just adding these together. So you don't do anything with the exponents. Okay, now in this last step, you're just going to take this minus 2 and you're just going to multiply it to each part. Okay, so that would be negative 2x squared minus 10x minus 12. The first thing you need to do here is get a common denominator, because this is a fraction and this is a fraction. Whenever you add and subtract fractions, you need to get a common denominator. So the common denominator between 2 and 3, that would be 6. So lowest common denominator would be 6. So you would first multiply this bottom part by 3, because 3 times 2 is 6. But what you do to the bottom, you do to the top. So put this in a bracket, and you're going to also multiply that by 3. This part, you're going to multiply it by 2. What you do to the bottom, you do to the top. Now, we put it in a bracket because there's more than one part at the top there. Now, be careful. This negative catches out a lot of learners. So what you're going to do is you're just going to write, you're just going to say one long line, you're just going to say 6. Then you're just going to write this part, and then you're going to say minus, and then you're going to write this part. Okay? Now, see how nice that was. Now you're just going to go multiply the 3 into that bracket and the minus 2 into that bracket. So that's going to end up giving 9x plus 6 for this part, 9x, and then plus 6. And then this minus 2 is going to become negative 20x, and then negative 2 multiplied by negative 3 is going to become positive 6. And if you then simplify that, you're going to get 9, take away 20. You can type that in the calculator if you want, but it's minus 11. And then you just say x. And then 6 plus 6 is 12. Simplify for 4 marks. Okay, so inside this bracket, there is nothing that we can really do. I mean, yeah, we might do something a little bit later, but for now, let's just leave that alone. There's not much we can do there. If there was a number on the outside, then we would do a little bit more. So I'm just going to leave that one for now. Although, what is this part? We know that anything to the power of 0 is just going to be a 1. So we can actually just take that out completely. You could put a 1 there if you wanted to, but that doesn't change anything. So we're just going to do that. Okay, that's my z squared. We could keep it in a bracket as well. And then 2 to the 3 and x7. Okay, nothing we're going to change there. Now here's where we're going to change quite a bit. The square root of 36 is 6. But now, what do we do with this and what do we do with this? Well, remember, if you have like x to the 8 over there, this is called an exponent. And then you've also got a number over here. If there is no number there, then it's automatically taken as a 2. So the exponent rule tells us that you're going to say x, and then you're going to take this number divided by this number, which would become a 4, like that. Okay? So if you take this number divided by this number, that's going to be a 3. And if you then take this number divided by this number, that would become a 2. Okay. Now, you can actually just take this bracket away. That bracket's not really doing anything. So now what we can do is there's multiple ways that you could carry on here. One of them is that this 6 and this 6 can cancel out. But if you chose not to cancel it out right now, that's also okay. It would eventually cancel later on. So I'm going to cancel that at this step. Okay. Then I know that this is 8. 2 to the power of 3 is 8. So I'm just going to go put minus 8 in the front. This minus is still there. And I also know then that this x3 and this x7, what is that going to be? It's not going to be x21 because we are multiplying these parts. But what do you do at the exponents? You just add them together. So that's going to be 10. Okay? And then you're going to get z to the power of 2. At the bottom, we can't do anything. Okay, now what we're going to do is we're going to look at these parts. You've got to know your exponent rules. So what is x10 over x3? Well, the exponent rule says that you take the top number minus the bottom number. So that'll be x7. So this is going to give us negative 8 x7. The z2 is still at the top. Nothing's happening there. And nothing's going to happen to this y2. So that'll stay at the bottom. And that would be our final answer. Here we have to solve an equation. Okay, so this is an exponential equation. So what we eventually want to have is a situation where we've got something like this. I'm not saying this is the answer, but this is what we are looking for. We'd like to have something like that at the end of it, okay? Or like maybe this will be a 5. So when these two numbers are the same, then that is good, because then we can ignore those numbers and we can just say that x is 5. At the moment, we don't have that. But what we know is that this number, if you type it on your calculator, just type that in so long, say 8, press the equal button, then press the shift button, then look for the part that says on your calculator, it says fact. It's not a button, but it's written just above a button. That'll give you 2 to the power of 3. What that means is that 8 can also be written as 2 to the power of 3. You know what that means? 8 is the same as 2 times 4, and 4 is the same as 2 times 2. So what they're saying on the calculator is that 8 can also be 2 times 2 times 2. Okay, and that's what 2 to the power of 3 is. Now, the next thing we're going to do is we are just going to take this entire part to the top. We know that when you move it to the top, the exponent number has to change. So at the moment it's a 3. Whoopsie. When you move it to the top, it must become a minus 3. Okay? There is that 1 that's still there. You could put it there if you wanted to, but that's not really going to do anything. So I'm just going to take that out. So remember that when you move something from the bottom to the top or the top to the bottom, its exponent always changes. If it was negative, it becomes positive. If it was positive, it becomes negative. But here we are now in this amazing position where those two numbers are the same. So we can now cancel them out, and we end up with x equals to negative 3. Solve the following equation. Okay, so the first thing that I see here is a fraction, and there's a plus, or it could be a plus or minus. So whenever we plus or minus fractions, we need to get a common denominator. So at the moment, this denominator is 1 and this denominator is 1. So the common denominator between 1, 2, and 1 would just be a 2. Okay, there we go. So what that means then is that we will have to multiply this bottom part by 2, and what you do to the bottom, you do to the top. Then this one, we don't need to do anything, okay? And then here we're going to have to multiply this bottom part by 2 and multiply by 2. I probably could have said times by 2 here and times by 2. Okay, so what we'll then end up with is 4x at the top, so that's 4x over 2 plus x minus 6 over 2 equals to minus 2 over 2, because that becomes minus 2. Now, listen to me carefully. When we are busy with equations where there is an equal sign and your denominators are all the same, you can get rid of the denominator. So then we just have 4x plus x minus 6 equals negative 2. Now, you're just going to solve for x. So we're going to take the minus 6 over to the other side. And on the left side, we're just going to have 5x, because 4x's plus 1x's just gives you 5x's. And then on the right-hand side, we're going to put the minus 6 as a plus 6. And so we now end up with 5x equals to, if you type this in a calculator or if you just work it out, it will give you 4. Then if you divide both sides by 5, it'll be 4 over 5. Solve the following equation. Okay, now this is super easy. Don't multiply the two brackets together. Remember, brackets are really good. Don't believe me? Well, let's say you had a question like this, and they said solve for x. Well, what you would do here is you would factorize this as a trinomial, right? And so you would do the whole trinomial kind of thing, where you would look at this number, which is a 4. Now, the number 4 is the same as 4 times 1 or 2 times 2. Then what you'd do is you'd either choose the top one or the bottom one and try and make this number, which is minus 3, okay? So how would you make minus 3? Well, you can't make minus 3 using these numbers, but you can make minus 3 using these numbers. How? By saying minus 4 plus 1. So we'll say minus 4 and plus 1, and then you say x and x. What would you do in the next step? Do you know? Well, you would then say that you would say this bracket is equal to 0, or the next bracket is equal to 0. See that? And so you'd end up with x equals to 4, or x equals to minus 1. So if you have brackets, then it's really easy to go to the answer. But what a lot of learners do, and I used to do this when I was in like earlier grades, like grade 10, is I would take this and I would think, oh, I should multiply it out. But then you're just going to go back to that step. But instead, you want to go down, don't go up. So all you're going to do is you're just going to say x plus 4 is equal to 0, or x minus 4 is equal to 0. And so therefore, x would be negative 4, or x would be positive 4. Solve the following equation. Okay, so when you have a situation like this, you just want to get rid of these brackets, okay? So you're going to multiply this 2 into the brackets. That'll become 4x, and then you're going to multiply it there, so that'll become minus 8. Then you're going to multiply it into here, that's 9, and then over here, which would become 12. Okay, now it's easy. You're just going to move x's to the one side, numbers to the other side. And so, I don't know why this is worth 4 marks. Like, honestly, this isn't too bad. So, we take all the x's to one side, all the numbers to the other side. So, I'm going to take this 4x that side, and I'm going to take this 12 that side. And so, we would end up with minus 8 minus 12 equals to 9x minus 4x. And so, it would end up with minus 20 equals to 5x. And now I guess it is 4 marks. You get 1 mark for that part, 1 mark for that part, 1 mark for that part, and then dividing by 5. So we're going to divide both sides by 5 so that we can get the x by itself. And so you end up with negative 4. Factorize. The first step of factorizing is always to try see if you can take out a common factor. Okay? Don't worry about trinomials. Don't worry about difference of squares. Don't worry about any of that until you have first thought about the common factor. So there is a common factor of 8, 12, and 20. What number can go into all of those? What is the biggest number that can go into all of those? The number 4 goes into all of those. You might say the number 2. That's okay. But later on in the question, you're going to have to factorize even further if you chose a 2. But I'm going to choose the biggest number straight at the beginning, which is 4. Now, this one has a M2, this one has a M8, and this one has a M4. So you can take the smallest one, which is M2, as a common factor. Now, what are you going to have left? Well, here you're just going to have a 2. Why do I say a 2? Well, imagine if you had to multiply this back. What would that give you? 8m squared, which is what we have. Excellent. Now, there's a minus. Now, this is going to become a 3m6. How did I get 3m6? Well, if you had to multiply this back over there, you would get negative 12. And then M2 and M6 would give you M8. See that? And then for this last part, it's going to be a negative 5 M2. Why? Because if you had to multiply this back, what would that give you? Well, that would give you negative 20, because 4 times 5 is 20, and there's a negative. And then M2 and M2 would give you M4. Now, you should technically look at this part and think if you can go any further, but there's nothing we can do, and it is only 2 marks, so that's it. Factorize for 4 marks. Okay, so whenever you've got the situation where you've got 2 of the same bracket, take that bracket out as a common factor. So that would be 2x minus y, which you take out as a common factor. Then what would you be left with? So you can imagine that that's been taken away. So now you're just left with a2 minus b2. Now that's not going to get you 4 marks. So what you do now is you look carefully. Can you do anything more with the bracket? Can you take out a common factor? No. Is it a trinomial? No. Can you do difference of squares? No. Okay, so, and there's no grouping, there's no cubics, nothing there. So let's look at this one. Can you take out a common factor? No. Can you do difference of squares? Ooh, maybe. The way to do difference of squares is you need to have two terms. Ah, that's good. So you need two terms. Whoopsie. So yes, they need to be separated with a negative. Yes. Each one must be a perfect square. Kevin, what is a perfect square? Well, here's a square. And if it's a perfect square, then this side and this side must be the same. If you then work out the area, what is a times a? A squared. What about a square that had b and b? Well, b times b would be b squared. So these are called perfect squares. The number 25 is also a perfect square. Why? 5 times 5 is 25. Is the number 20 a perfect square? Nope. Because there's no number that you can put here and no number that you can put here. That's the same number that'll give you 20. Yeah, but Kevin, what about 5 and 4, my bro? Yeah, but I said it has to be the same number. Ah, okay. You see. So, there we go. So, this is a perfect square. So, we make two brackets, and we'll say a minus b, and then a plus b. Remember, you always take the square of that one, the square root of that one. That's where I got the a, and I got the b. And then you make two brackets, and one of them's a minus, one of them's a plus. And there we have it. 4 packets of biscuits cost 74 Rand. What will 6 packets of biscuits cost? Okay, so 4 packets of biscuits. Let's go draw out 4 packets of biscuits. There we go. Now, if you go buy all of that, that'll cost 74 Rand. Now, they want to know what would 6 biscuits cost. Okay, so what we'll do is we'll take this part and we'll just go work out what is the price of 1 pack of biscuits. So you could say 74 divided by 4, and that'll be 18 Rand 50 per 1 packet, or per packet, okay? Now we're going to do 6 packets, so we can just say 18 Rand 50 multiplied by 6, and that'll be 111 Rand. 6,000 Rand is invested for 3.5 years. Calculate the value of this investment. If it is okay, so the first question says if it is invested at 12% simple interest. Ah, okay. So we know that these formulas, okay? This is the simple interest formula. Now, let's just go through what everything means. P is your starting amount. A is your final amount. I is the percentage. N is the years. Okay, so, or actually we can say I is the percentage, N is the time, because sometimes, I don't want to say years because sometimes they like to do weird questions. Okay, but this one says 12% per year. Okay, that's what that means per year, and it's 3,5 years. So we will say that the final amount is going to be equal to 6,001 plus, now this part is 12%, so you can just say 12. You can either say 12%, but then you must put the percent on your calculator, or you can say 12 over 100, or you can just say 12 over 100 and then type the answer, which is 0.12. It doesn't matter. Now, the number of years is 3,5. There we go. Go ahead, type that all in on the calculator. And that investment will be worth 8,520 Rand. Okay, so that's this question. The next part says, okay, do the same question, but now we're going to use compound. Ooh, compound is a different formula, so it goes like this. Okay, so we're going to say A equals to, let's just say that this was the first question. This is the second question. So that's going to be 6,000. 1 plus, now the percentage is still going to be 12%, so 0.12, but now you're going to say 3.5. Compound interest always makes your money grow faster. Let's see. Okay, 8,921 Rand. And then if you round this to 2 decimals, 0.02. Okay, now you see how it's a little bit larger than that. Okay, now this question over here says, which is the better option between the two investments? Well, definitely the one that gives you more money. So we would say the compound. Let's say that this is this question. We could say the compound interest investment. A car travels at an average speed of 90 kilometers per hour. How far will the car travel in 3.5 hours? Now, a lot of learners, they just use the formulas But I think that that's okay. But for this first one, just think about it carefully. I want you to get a bit of confidence in this. Think about this. They're telling you how fast this car can drive. They're saying that it can go 90 kilometers every hour. Think about that for me. In 1 hour, that car would be able to drive how far? 90 kilometers. So then how far would it go in 2 hours? Well, if you say 90 for the first hour and then it drives 90 kilometers for the second hour, then it will be able to go 180 kilometers. In 3 hours, well, then it will be 90 for the first hour, 90 for the second hour, 90 for the third hour. So it will be able to drive 270 kilometers. Okay? Now, of course, we can use the formula. The formulas that you typically use is the, I'm not sure if your teacher uses the DST triangle like that. But what it means is that, okay, so let's start with distance. So you see distance is at the top. So we say that the distance is equal to these two multiplied together. Okay? Now, let's say we wanted to find the speed. So then you could say S equals to, now you see the D's at the top and the T's at the bottom. So you do it like that. It's a divide sign. And then if you use T, so if you use this one, then the D's at the top and the S is at the bottom. So D's at the top, S is at the bottom. So those are the three different formulas you need to know. Okay? But I just wanted to show you this part so you can just get an idea of what's actually happening here. So this first question says, how far will it travel in 3.5 hours? Okay, so we know the speed. This is the speed, this is the time, and we're trying to find the distance, how far. So we'll use this formula. So the distance is equal to the speed. Now the speed is 90, and the time. Now always make sure that these two are the same. See, this is hour, and this is hour, so that's good. So 3.5. I'm going to say 3.5. It's the same thing. It's just I don't like learners who type 3.5. I don't like it when they do that because on a Casio calculator, if you don't type this number in the correct way, it gets your question wrong. I'll quickly talk about that. So on a Casio calculator, you mustn't just push the fraction button, the one that looks like that, and then just try put a random number here. Like you don't want to put a 1 over here and a 2 over here and then you try put a 3 over there. It won't work. If you want to type a number like that, a mixed number on your Casio calculator, you must first press the shift button, then press the fact button, and then it'll open up. Oh, then press the divide sign, which is that one over there. Well, not the divide sign, but the fraction button. You know, the one that gives you the fraction. And that'll automatically give you a little block in the front. And then you can put the 3, the 1, and the 2. Okay? So if you do that, you get 315. 315 what? Seconds? No, kilometers, because it's distance. Okay, now this question says, how long will it take the car to drive 390 kilometers at the same speed? Okay, so for this question now, we have the speed. They want us to know how long, that means time, and we know the distance. Okay, so we're looking for the time, so we'll use this formula. So time is equal to distance over speed. So the distance is 390, and the speed is 90. And then if we round that to 2 decimals, it'll be 4.33. And then we can just say hours, like that. The table below shows the relationship between the ages of a mother and her son. Okay, so the mother is 25 and then the son is 1. The mother's 30, blah, blah, blah. Okay, we get it. So it says determine the values of A, B, and C. Well, what you got to do is just look at this. If the mom is 25, then the son is 1 year old. So how much older is the mom? Well, the mom is going to be 24 years older than the son. So mom is 24 years older than the son. So then it's easy. Because now if the mom is 30 years old, then how old would the son be? Well, the son would just be 24 years younger than that. It's always going to be 24 years younger. That'll never change. So then so A would just be 30 minus 24. So that would be 6. So A is 6. Now to find B, so now the son is 26. So how old is the mom? Well, remember, the mom is always going to be 24 years older. That never changes. So you could say 26 plus 24, and the mom is then 50. So that would be a 50. Wow, time is progressing. Now the mom is 70 years old. Well, guess what? The son is still going to be 24 years younger. So you could just say 70 minus 24, and that's going to be 46. So C would be 46. Now it's quite interesting when you check on the memo, they got this one and this one incorrect. They just minused 20, no, for this one they minused, or they added 25 instead of adding 24, and then here they added, I think, 25 instead of 24. So it's completely wrong, but I promise these answers that we have here are correct. Okay, this one says, how old will the son be when the mother is 92? Well, when the mother's 92, guess what? The son will still be 24 years younger. So you can just say 92 minus 24, and that would be 68. Consider the number sequence 4, 9, 14, 19. It says write down the general term of the number sequence. Okay, so what they're doing here is they're adding 5 each time. You see that? So we know that that is called a linear number pattern. Now, different teachers use different formulas, but one of them goes like this. Now, as I said, there's different techniques, but what we must know is that this letter here, whatever letter your teacher chooses in front of the N, is always going to be this number here that you are either adding or subtracting each time. So we're going to put a 5 over there in the place of A. Now, there are different ways to find B. B is actually this position. It's this number that would be over here. So this is position 1. So that's position 1, position 2, position 3, position 4. B is whatever you would have at position 0. So how would you find that? Well, instead of plusing 5 to go that way, you can minus 5, and that would be 4 minus 5, which is negative 1. So B is negative 1. Okay, if you don't want to find B like that, then your other option is you could have done the following. You could have chosen any one of these. Okay, let's say you chose this one. Then what that means is that this value here would be a 14. The value of N would be, this is position 1, this is position 2, this is position 3. So you'd put a 3 over there, and then you would say plus B. And so you'd end up with 14 is equal to 15 plus B. If you get the B by itself, it would be 14 minus 15, and that would be negative 1, just like we got over there. So 2 different ways of doing it. It's up to you what you want to do. And when I chose 14, you could have chosen any one of those numbers. Okay. What's next? Okay, so now it says, which term will be 64? So now here's where learners get confused. They don't know whether they should take that 64 and put it there, or whether they should put it there. Well, let me explain. Okay, so in this sequence, the TNs are going to be the numbers 4, 9, 14, and 19. N is going to be position 1, position 2, position 3, position 4. Okay, so they're saying which term is equal to 64. So would the 64 go in this pattern or in this pattern? Well, it's a value, so it's this one, okay? But we got to know what is the N value. So we're going to say 64 over there. A we said was 5. N we don't know. And then B is negative 1. If you take that negative 1 to the left, you end up with 65. And then on this side, you would have 5n. Okay, so then you're going to divide by 5, and you end up with 13. So that means which term in the sequence? It would be term number 13. From the list of 2D forms below, identify all the quadrilaterals that meet the following characteristics. Okay, so we've got kite, rhombus, trapezium, hexagon, parallelogram, square, and rectangle. And they said which one of those where the diagonals are perpendicular bisectors. Okay, that's interesting. So let's go draw each of them, okay? Oh, Kevin, come on. Can't we just get done? Guys, let's just draw them, okay? Just chill. I want to help you guys understand a few things. So let's just go draw them out. There we go. A rhombus, because some of you might even not remember what each shape is. That's a kite. And here's a rhombus. Whoa, Kev. A rhombus is like a square. So the sides have the same lengths, but it's tilted to the side. Okay, so that's your rhombus. Oh, and I must draw diagonal lines. Okay. A trapezium. So trapezium just has 2 parallel lines, but the shape can look really weird, like that, for example. Okay. What's next? Oh, let's just say here, trapezium. So if you had to do the diagonals of a trapezium, it would look like that. Okay. Hexagon. So hexagon is a 6-sided shape. Okay, so that is a hexagon. So this one has a lot of diagonals. You know, it could go like that, like that, like that. You know, there's a lot. And yeah, I could go to, I'm not going to go draw all of them, but you get it. Okay, a parallelogram. Parallelogram has parallel lines and parallel lines. So it's almost like a rhombus, but in a rhombus, all of the lengths are the same. Okay, and if you had to draw that, okay, I don't know why I've got parallel lines, because I didn't do it for the others. Okay, a square. You know what? I've heard of a square before? Of course you have. Okay, square. And then a rectangle. Okay, diagonals and then square. Okay, so the first question says the diagonals are perpendicular. Let's first look at that. Perpendicular means that they hit at 90 degrees. So for a kite, yes, they hit at 90 degrees. For a square, yes, that is 90 degrees. For a parallelogram and for a rectangle, they actually don't hit at 90 degrees. That's not 90 degrees, and that is not 90 degrees. For a rhombus, it actually is 90 degrees. Okay, so that's the first part, perpendicular. Bisector means cuts the diagonal in half. Now, this one's not a bisector, because look at this diagonal. Okay, does it cut this line in half? No, it doesn't. This part is not the same length as this part. So a kite is out. Sorry, kite, but you out. Go fly your kite. Wow, okay, that's lame, bro. Okay, trapezium, no, you were never in the first place. Square, does it cut it in half? Yes, this is definitely the same as that, and that is definitely the same as that. So a square is definitely one of the answers here. Okay, what else? Who else did we say was in? Oh, a rhombus we said was in. And with a rhombus, yes, this and this and this is definitely the same, and then these two are definitely the same. They're not all the same as each other, but this and this is the same. And that's all that they said. Do the diagonals cut each other in half? So that's in half and that's in half. Yes. Okay, so it looks like it is a square and a rhombus. Okay, then this one says, the diagonals are not equal in length, but they are perpendicular. Okay, so the only ones that were perpendicular were the kite, the square, and the rhombus. So only looking at those, the diagonals must not be the same length. Okay, so for a square, the diagonals are the same length. So that's not going to work. Here, the diagonals are not the same length. Like, look how long that... Let me actually use a different color. Look how long that diagonal is compared with that diagonal. Okay, so that's not going to work. I mean, those diagonals are not the same length. So that is going to work because they said the diagonals must not be the same length. So that's going to be a kite. And then a rhombus. Look at this length. That's much longer from here all the way to here. That is much longer than this piece over here, which is only from here to here. So the lengths are not the same. So that's good. They said that the diagonals are not equal in length. So that's also going to be a rhombus. The sum of the inside angles of an n-sided polygon can be calculated using this formula. Now let me show you. This formula is actually really awesome. It says that if you have, for example, a triangle. Now we know already that what do the angles of a triangle add up to? 180. But let's say we didn't know that. Then some mathematician back in the day said that if you don't know how much the angles must add up to, just use this formula. So the formula is n minus 2 times 180. Now n is the number of sides in the triangle. So this one would be 1, 2, 3. So you would say 3 minus 2. So 3 minus 2 is 1. And that would give you 180. So that means all of the angles inside this triangle must add up to 180. What if you have a four-sided shape, like a rectangle? Well, we know that the sides of the four angles inside a four-sided shape must add up to 360. But let's say we didn't know that. Then you could use this formula. So now you have four sides. So we could say 4 minus 2 times 180, which gives you 2 times 180, which is 360. You see that? So this formula is actually really cool. If you know how many sides you have, you can work out what the inside angles would be. So now some learners are going to get confused here. You mustn't look at all of these sides. They're talking about the outside length. So there's 1, 2, 3, 4, 5, 6, 7. So that's a 7-sided shape. So you'll say 7 minus 2 times 180, which is 5, times 180, which is 900 degrees. The diagram below shows a regular polygon with central point F. Now, a regular polygon means that everything's equal. So this side and this side, everything is the same. It's completely, all of the parts are the same lengths, everything. So it says that AF is equal to BF. So this length is equal to this length, which is equal to this length, which is equal to this length, which is equal to that length. And then F1 is equal to, so all of these angles are equal. Okay, so they said calculate the size of the angles with calculate the size of the angles with vertex f. So they want to know what are each of these angles. Well, this is super easy, guys, because we know that that is a circle. Or like, not a circle, but like you're going all the way around a point, okay? So we know that the angles around a point must add up to 360 degrees. Now, there's different reasons that your teacher might use. They might say, or let's first say here that f1 plus f2 plus f3 plus f4 plus f5 must add up to 360. Now, one of the reasons is angles around a point, or some teachers just say revolution, for example. Okay, so if all of those add up to 360, then what would each of them add up to? Well, you could just say 360 divided by 5. Yeah, but Kevin, how do we know they're all the same? Because they said it's a regular polygon. So we can then say 360 divided by 5, and that would be 72 degrees. Okay, so just to let you know that there will be another question coming up after this one. So you've got 7.1 and then we've got this 7.1.2. Okay, and they gave us this weird table thing here. So I just decided to add it. Okay, so what they're saying is that ABC is a straight line, and they tell us that this angle is that and that angle is that. And now they want us to find the value of x. So we know that if you add these two, we know that this is the angles on a straight line. So together, these two angles must always add up to 180. So you're going to say 180 there. Then for the reason, you're just going to say angles on a straight line. Okay? Now your teacher might do that a little bit differently, but I mean, that's the basics. Angles on a straight line. Now the next step, we're just going to go down to this part here where we're just going to simplify. So 5x take away x is going to be 4x. And then we're going to take this 30 and 90 to the other side. So that'll become 180 plus 30 minus 90, and so let's just simplify that. So that's 210 minus 90, and so that's 120. We divide both sides by 4. Oh, you don't have to give a reason. That's why they've put a gray block. And then you can just divide both sides by 4, and so x would be 30 degrees. Now this next part says, hence, calculate the value of ABE. ABE, so A to B to E. So they want to know, what is this angle? Now remember, we know that x is 30. We just worked that out. Now you don't have to give any reasons because you can see there's nothing here. So we're just going to say 5 times 30 minus 30, you see, because x is 30. And so that's going to give 150 minus 30, which is going to give you 120 degrees. 4-mark question, here we go. In the diagram below, AC is parallel to DF. DG is parallel to CE. Okay, they've showed us all of that. ABG is 110 and CEF is equal to x. CEF is equal to x. Okay, so they say determine the value of x. Okay, and that's for 4 marks. Okay, well, there's so many different ways that you could actually do this. Oh, but luckily they've told us what to do. Okay, so they're saying DBC. So angle DBC. Okay, so that angle there would be the same as that angle there. So that, because of vertically opposite. You see that? So I like how they've given us this. So they said 110. This isn't my thing. This is what they said. Now the reason will be vertically opposite angles. Okay? So that's 110. Excellent. So now they're saying BDF. So where's that? BDF. Okay, well here what they're wanting us to use is this parallel line over here. Now can you see that there is a F kind of shape? See it? That's an F. Whenever there's an F, then it means that this angle and this angle is the same. So we can say that BDF, which is this one over here, is equal to x, and that is because of corresponding angles, and that is because DG, line DG, you could also say DB if you wanted to, it doesn't really matter, is parallel to EC. Okay, so we've got an x over here now. Okay, then I'll say angle DBC, which is this one, plus BDF, which is this one, what should they add up to? Well, we know that they should add up to, because of these parallel lines, what kind of shape do we have there? Well, that is a U. And if you understand your parallel lines, you know that with a U, it's called co-interior, and the U's always add up to 180 degrees. They always add up to 180, and that is because of co-interior angles, because BC, the line BC, is parallel to DF, okay? And so what we can then say is DBC, which is 110, plus BDF, which is x, must add up to 180. So then to get x alone, you would end up saying 180 minus 110, because you take it over to the other side. And so x would end up being 70 degrees. In the diagram below, they say that triangle ABC, now some learners struggle. What does this mean? Well, remember the 3 lines that way stands for similar. How do I see that? There, there, and there. There's 3 eyes. See it? Whereas if the lines are like that, well, that's congruent. How do I know that? See the 3 lines? Oh, yeah. Okay, so these 2 triangles are similar. We don't have to prove that they're similar. They've told us they are similar. So it says determine the value of x. Okay, so now we know when 2 triangles are similar, you can make those different fractions. You know, like if you have ABC similar to DEF, you can then do that AB over DE equals to BC over EF, which is equal to AC over DF. Okay, so we just got to see which one they're looking at. So they want the value of x. Okay, so we definitely want to use BC and EF. So let's just get the order right. BC and EF. Okay, so BC is at the top. And let's just go BC over EF. Now, for the reason for that, you know how I said here that when 2 triangles are similar, we can say these reasons, or these fractions. Now, there are many different reasons that I've seen. So one of them is that you can say because the reason is because these 2 triangles are similar. So you can just do that. But have a look and see what your teacher says, okay, for that part. Now, we're just going to go fill in the values. So AB is 3, DE is 6, BC is x, and EF, which I'm following here, is 10. Now, some learners do struggle with how to handle this. For example, 3 over 6 equals to x over 10. There are different ways of doing it, but one of the ways that I see a lot of learners love doing is cross multiplication. So you take the 10 up across there and the 6 across there. So it ends up becoming 3 multiplied by 10. So 3 times 10, which is 30. And then 6 multiplied by x, which is 6x. Then you divide both sides by 6, so you can get the x by itself, and that's going to give you 5. In triangle PQR, okay, then they give us the lengths. Okay, that's great. And then they say, determine whether this triangle is a right-angled triangle. Okay, so to determine whether something is right-angled. Now, obviously, you might say, yeah, but there's no right angle here. But guys, they're not going to draw it according to scale. Now, we know that if something is 90 degrees, then what do we normally use? Pythagoras. If it is 90 degrees, okay? But let's go use Pythagoras anyways. So we know that Pythagoras tells us that if you have a right-angled triangle, then if you take these 2 sides, the smaller sides, and you add them together with a square like that, then it should be the same as this one squared. If that is true, then it's a 90-degree triangle, because Pythagoras only works for a 90-degree triangle. So check this out. Here's the longer side. So let's take these 2. Let's go add them together. But remember to square. That's important. And let's see what we get. After typing that on my calculator, I get 1,600. Now I'm going to take this one, and I'm also going to square it. And what does that give us? It's also 1,600. So because Pythagoras is actually working, so if these 2 numbers were different, then we would say Pythagoras didn't work. But these 2 numbers are exactly the same, so Pythagoras is working. So what we can say is yes, triangle PQR is a right-angled triangle. The diagram below shows rectangle PQRS. Rectangle PQRS, there we have it, okay. With PQ parallel to SR, they've showed us that. And then angle Q is equal to angle S. Okay, they didn't show us that, so we need to make sure we understand that. But they obviously would be the same because we know that in a rectangle, those are 90 degrees. This question says, prove that this triangle and this triangle are, what does that mean? Well, that means congruent. How do you remember that? Well, in the word congruent, there are 3 parallel lines, And then in the word similar, which I actually found out recently, you're not actually supposed to spell it with the I. It's actually spelled like that, similar. But whatever. So like if it helps you to remember that with similar, there's 3 I's. So similar triangles have 3 I's, whereas congruent triangles has 3 parallel lines going down like that. Okay, that's how you tell the difference between them. So congruent is when the triangles are exactly the same, and there are 4 different types: side, 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 angle, side, side, angle, angle, or right, RHS, which stands for right angle, hypotenuse, and a side. Okay, so let's have a look. They say in triangle PQR and PSR. Okay, so we need to try to figure out what's the same. Well, the first thing is that these 2 sides are going to be the same as each other. Because if you pull this triangle apart, if you pull PQR away from PSR, well, look, they both have PR. So that's going to be PR is equal to PR. And the reason for that is what we call common. Well, this question's actually a little bit silly. They shouldn't have told us it's a rectangle. They should have just said quadrilateral, because we know it's a rectangle. So we know that these 2 sides are the same, and we know that these 2 sides are the same. So we can actually just go do that. They didn't need to tell us all this extra nonsense if it was a rectangle. So if I was them, I would have just left this out completely, and I would have just said quadrilateral. But because it's a rectangle, we already know all of the properties. We know that in a rectangle, all the opposite sides are the same, and so it's pretty easy. I'm just going to go straight for this one. So we can just say that PS is equal to QR, and that's just because of the opposite sides of a rectangle, okay? And then PS and QR, okay, then we could say PQ is equal to SR, and that's also because of opposite sides of rectangle. So then we can say, therefore, these 2 triangles are congruent, and that's just because of side, side, side. TK is the diameter of the large semicircle with the center at P, okay? So that's the diameter, all right. TP and PK is the diameter of the 2 smaller semicircles. Okay, so he has a semicircle, and so TP is its diameter, and then he has another semicircle, and PK is its diameter. They say that TK is 2 times the length of TP, which is 24. Okay, so they're saying that TK is 24. Okay, so that whole length is 24. And then pi is 3.14. So it says complete and calculate the perimeter of the shaded region. So that would be all of this plus that plus that. So they're breaking it down for us, okay? This wasn't me. This is what the exam paper looked like. So they're saying, what is the circumference of the large circle? Well, the circumference of the larger circle, to calculate circumference, you normally say 2 pi times radius, okay? So, but then you're going to half that because we only want half of it. That's why they're putting a half over there. So we can just say half of 2 pi radius, because 2 pi radius gives you a full circle. But then by them putting a half in the front, it halves it. So that's good. So we could say, you might use a different formula for this. Some learners don't use 2 pi radius. Instead, they just use pi times diameter. Both are perfect. But I'm just going to use this one because it's the most popular. So that's going to end up giving you a half times 2 times 3.14 times the radius. Now that's the radius of this big circle. So if the diameter is 24, then the radius would just be 12. And if you had to work this out, 37.68. And that would be centimeters because, yeah, they're using centimeters. Okay, now they're going to use, they're saying that there are 2 half circles. So you see how we have 2 half circles over here. So there's a half circle and there's a half circle. So, okay, so to calculate the circumference of a normal circle, it's going to be 2 pi radius. Okay, so we're going to say 2 pi radius. But how many circles do we have? Well, we have 2 of them. So I'm going to put a little 2 over here. But then we don't have the full circles. We only have half of the circles. So I'm going to put a half over there. And so we're going to say 2 circles. Each circle's circumference is 2 pi radius, but we only want half of that because, yeah, you understand, right? So, okay, so then if you had to work this out, it's going to be 2 times a half times 2 times pi, which is 3.14, times the radius. But now we're looking at the radius of these smaller circles. So if this length is 12, then the radius of that circle would only be from the halfway point to there. So it would be 6, like that. And so if you had to go calculate all of that, that'll be 37.68 centimeters. Just normal centimeters, sorry. And so the perimeter of the shaded region would be the big circle, which we've just calculated, and then the smaller part, which we've just calculated. And so if you just had to add those two parts together, that'll be 75.36 centimeters. This question says, construct a triangle KLM. They want angle K to be 120. And then they say that KO is 8 centimeters and MK is 6. Okay, so they've asked us to do a construction. So you need to go and get a protractor. And let's just start over here, put a little dot. Just draw a long ruler line, okay? And put your protractor like that, for example, where you've got your protractor on that dot. Measure 120 degrees. So 120 degrees would be about there, okay? And then just draw a line going like that. Okay, so this would be K. This angle is now 120 degrees that you've measured. Now, they say KL is 8 centimeters. So draw this line. It doesn't really matter, but let's draw this line, 8 centimeters. So maybe it goes up to there. So then you can put L over here and you can erase that part over there. And then KM is 6 centimeters. So measure 6 centimeters with your ruler and then cut it off over there. And then you can erase all of that. And then you just connect the two parts. Let's see if I can do this nicely. Obviously, you would have a ruler. And that's what you would do, okay? So this would be 6 centimeter on your ruler. This would be 8 centimeter on your ruler. And then this part you've measured with a protractor to be 120 degrees.